logarithmic functions, similar to square roots and the exponent of 2. They undo one another. Logarithms and exponential functions sort of undo one another as well. So just to start off, it says, okay, solve for x in each of these cases. For number 1, it says 10 to the x power is equal to 100. Well, hopefully that one is pretty simple. You're like, oh, it's 10 squared, so x here in this case is equal to 2. Similar for numbers 2 and 3. 10 to what power gives you 1,000? You might be like, oh, that has 3 zeros, so it's x is equal to 3. Same thing for number 3. 2 to the 3rd power is going to give you 8. For number 4, well, anything to the 0 power is going to give you 1. You should know that off the top of your head. So therefore x is 0. Whenever we get to number 5, that's where it starts getting a little bit tricky. We can't mentally do it. It's becoming a decimal. That's a very hard decimal to guess and actually have accuracy. And for real-world applications such as earthquake magnitudes, carbon dating, anything of that nature, it's not that great just to use a decimal approximation and sit there and guess and check forever. Like, you need something accurate. So that's where logarithms came from. Logarithms help you find a missing power. Here, this whole situation right here, if I have, say, 2 to the x power is equal to 16. Hopefully you realize x is 4. If I'm writing it with a log, I put the log. The base of the log is the same base as the exponent. So log base 2. It's a subscript. It's a smaller 2 and it's to the side. Just like how you see the 5 and the 10 for 8 and 12 below. And then 16 is equal to x. So what it's basically saying is, hey, log base 2. 2 to what power is going to give you 16? And we're able to use a calculator to estimate those decimals. So that's really what it's talking about. Important. B always should be a positive real number. So all of our bases so far have been positive. If there was a negative in the front, we assume that was A, not the base itself. The base cannot be equal to 1. If you have any log with a base b that follows suit of what we just discussed, to say it's log base 3 of 1, guess what? It's always going to be equal to 0. Because what it's asking is 3 to what power is going to give you 1? Well, anything to the 0 power is 1. So log of 1 is always 0. So we're asked to rewrite the expression for 6 through 8 as exponential form. So again, what it's saying is, okay, the log 3 to the 2nd power is going to give us 9. So we rewrite it. 3 to the 2nd power is equal to 9. The answer for a log is the exponent that goes along with the base. For number 7, we put 8 to the 0 power is equal to 1. For number 8, we put 5 to the negative 2nd power is equal to 1 over 25. Again, negative exponents turn things into fractions typically. For numbers 9, 10, 11, and 12, we're asked to rewrite the expression to find the answer without using a calculator. So what this is asking is, it's saying 4 to what power is going to give us 64? Well, hopefully you can do this one easily. That number has to be 3, so this log is 3. Here, they're saying 2 to what power is going to give you 1 over 8. it's taking the base and it's making it into a fraction. So that automatically tells me that it's going to be negative. And then I think, oh, 2 to what power is going to give me 8? 3. So I say it's negative 3. For number 11, it's saying 32. To what power is going to give us 2? Since you're taking something and you're making it smaller, you might think, wow, this is a negative exponent. It is not, because it doesn't make anything into a fraction. This is where we have to go back and think about our rational exponents, where the exponents themselves were fractions. I know that 2 to the 5th power is going to give us 32, so that means the 5th root of 32 is going to be 2. We write the 5th root as an exponent as 1 over 5. For number 12, log base 10 of 1 over 10, it's saying 10 to what power is going to give us 1 over 10? Well, it's changing it into a fraction, so I assume it's going to be a negative exponent, and it's staying itself, so negative 1. Just to go through this, and then I just want to do a little example from Odyssey-ware that I saw. The common log is with a base of 10. This is typically how you always see it in a calculator. It is denoted as log base 10, like we just saw in number 12. But more typically, especially in a calculator, it's just noted as log. The natural log is a logarithm with base e. It is denoted as either log base e. You never see that. You'll never see that anywhere. But more typically, we put it as ln. Your calculators, the graphic calculators at school, have keys for e, log 10, and ln. If you go to Google and just Google a scientific calculator, you should see all of those. Even more specifically, you can Google like log-based calculators, and you should be able to pull that up and approximate these in the calculator very easily. Should take you a few seconds. Last thing I want to put in this video, saw a question on Odyssey-ware that looked similar. It wasn't exactly like this. It was like log base something of x minus 1, and they said it was equal to I don't know, 2. Making this up. So in reality, what this is saying is it's the same thing we did for numbers 6 through 8. It's saying 3 squared is equal to x minus 1. Because in reality, that's what it means. 3 to what power is going to give us x minus 1, and it's giving us that exponent. Well, hopefully you know 3 squared is 9, so I'll put it over here. So 9 is equal to x minus 1. And then just add 1 to both sides and be like, oh, x is 10. Plug it back in, it should work, but that's the general gist of what it was doing in Odyssey-ware. I saw a few questions like that. The graphing part, whenever you get to that on Odyssey-ware, I would use Desmos to check yourself. Because graphing logs, and you'll see that more so ahead, can be a pain. I'll do another video on logs, doing the properties of logs, or I already found videos, but more specific videos to this in the near future, so that way you sort of have that idea as well. So I'm going to stop and post it, and hopefully it helps.